Good morning, ladies and gentlemen. Welcome to this session. My name is Joan Casas, from UPC, Barcelona Tech, and I will be sharing the session jointly with Professor Rede Haigdin. And as you know, there has been a small change in the program, but we have this keynote presentation, and it's my pleasure to introduce you the keynote speaker this morning, which is Irina Stepanovic. Dr. Irina Stepanovic is founder and managing director of Infraplan Consulting and visiting professor at the University of Twente at Construction Management and Engineering Department. She received her PhD at the University of Zagreb on the topic of service life of concrete structure in marine environment. Irina has extensive experience in research and development projects and professional activities related to sustainability of construction materials, life cycle management, risk and climate change impacts on transport infrastructure networks, and she has worked for more than 20 years in academia and industry in Croatia and in the Netherlands. And she has been active also member in the number of technical committees in FIB, RILEM, and standardization groups. She's currently the vice president of our association, EUROSTRUCT. So Irina, the word is yours.
Thank you very much. And thank you very much for giving me the opportunity to give a talk on circularity in infrastructure management. So why do we need to implement circular economy in transport infrastructure management? As you know, we have to manage a lot of transport infrastructure networks, which are most resource-intensive industrial sector in the EU. It uses around 50% of available primary raw materials, hence exhausting the natural resources, degrading environment, and generating high costs to the business operators. Transport infrastructure is also exposed to a number of challenges. So we have a significant growth in population who want to work and live in the urban environments. So we expect to have increased urbanization. 2/3 of the population by 2050 should live or want to live in the cities. And we have climate change impacts. We have experienced a number of extreme events which caused a lot of problems on our networks. So all that we are considering under very constrained budgets and very limited resources to maintain the required performance. So beside that, we are still continuously extracting the resources. The world economy is still linear, unfortunately, and the extraction of natural resources plays a significant role. We have made some efforts. You can see on this chart, the numbers are stagnating, so they are not anymore increasing, and fossil energy materials are decreasing, but our most natural resources are still static. So we didn't do enough. Besides that, we are claiming that we are really recovering construction and demolition waste almost up to 100%. The average rate in Europe is 88%. And Europe has set a goal by 2030 to have minimum 70% recovery of the construction and demolition waste. We happily say we have achieved that. But there is a big but. Backfilling of the construction and demolition waste is considered as a recovery. And unfortunately, it is not. It is downcycling, and it is linear value chain. So if you look at this graph, backfilling is actually, if backfilling is not taken into account, then only few countries have reached this goal of 70%. So we have to go away from this backfilling of construction and demolition waste. We have to start thinking that construction and demolition waste is a source of new materials. And finally, we can say, so these numbers are really bad. We are bad players in the society. So as a built environment, we are producing 50 to 70% of the global resource extraction of sand, cement, and steel. We are producing almost 40% of the global greenhouse gas emissions. We are consuming 40% of the global energy. We are landfilling, as I already said, 50% of the waste, global waste. We are polluting water. Also, 40% of the global water pollution is related to the building and construction industry. And 60% of the global population wants to live in the urban environments. So what is our way forward and how we can improve that? There are opportunities. there are new policy measures, there are new frameworks, new strategies. And this is one of the waste frameworks. So there are different approaches to the circularity. But if we go uphill these ladders, we definitely would achieve a better circularity integrated into transport infrastructure management. So what does it mean, a circular value chain? The circular value chain, sorry. A circular value chain means that we start from after demolishing our buildings and crushing bricks, tiles, and ceramics or other materials, that we have to carefully separate them. We have to check the quality control, and implement them in the new process or in the new materials. But even better, we shouldn't demolish, we should actually reuse. So imagine that we just moved, so at the moment in Europe, only 7% of the construction and demolition waste is used as an aggregate in our new structures. If we move from 7 to 20%, we would save 6 billion euros annually, and we would reuse 546 million tons of aggregates. So there are big opportunities in our construction and demolition waste. This is an example of the bridge in London, which was dismantled, and they were very proud how they dismantled because of the environmental conditions or the city-urban environment, but then they said they brought it to the site, they crashed it and recycled. So why not to reuse these beams or structural elements? Of course, they need to be repaired, they need to be strengthened and checked, but we can reuse a lot of our existing infrastructure elements. So this is a usual practice to demolish and replace. So we should go away from that. There are nice examples of already reusing structural elements. This is an example of wind blades, and wind blades are also a huge problem in the future. They have relatively short service lifetime, 30 years, and they are now landfilled around the world. So this is a fiberglass element and could be reused in a number of cases. This is a very nice example from the Netherlands, financed by Rijkswaterstaat, a Dutch Ministry for Water and Highway Management. They have built a bridge which is completely circular. Less than 1% of material cannot be reused, and it's actually a grout which is poured only between the joints of the elements. So each beam consists of 20, as you can see, prefabricated concrete elements, and they have a special shear joint, and then they are connected, and they are structural beam on the bridge, which is 20 meters long and 7.5 meters wide. So the examples are there. It has been used at the construction site, completely dismantled, and now in one city in the Netherlands, put back for the public use. There are also a number of examples how to use or reuse our existing structures, including the foundations, including strengthening the existing bridges. So we have to look for the new materials. We have listened yesterday to the very nice talk from Professor Eugen Brühweiler, who spoke about using ultra-high performance fiber-reinforced concrete also for strengthening existing structures. So how digitalization can help the transport infrastructure become circular? We have to link design with our existing structures. That means that we have to introduce a matchmaking. So what is the supply or what is existing with the new needs? And somehow we have to, of course, first digitalize and record what we have. We have to assess the quality and, we would say, put some certificate on it and validate, and then we can use it in the design back. All that is actually also enabled by current policy and current law. We have a green public procurement put as a mandatory in Europe, and worldwide it can be applied. The problem is that we have not metrics which can be used, and in most European countries there are still a number of barriers for implementing a green public procurement. So what we were thinking in one project, we want to develop a digital platform which will actually use the digital data of the existing infrastructure, existing structures, That means that we have to digitalize, develop a BIM models, and then add a circularity indices, KPIs, which will be used in the circularity analytics tool. So what can be reused, what can be recycled, and what necessarily needs to be landfilled. In that sense, we have a tool where the materials will be like a database or like a library, and we can connect it with the future needs. So we want to develop also a supply matchmaking tool. If we look in this circular process, so we start from existing buildings and infrastructure, we digitalize and analyze, we have a circularity analytics tool, and then we have a waste database. We can also implement other industry waste. We are already doing that. We are implementing heavily fly ash, slag, and other ashes types in the cement industry, glass to a certain extent. Steel is completely recycled, but we would like to add another waste, for instance, as I showed with the wind blades. We deconstruct our structures. We want to actually upcycle the waste. That's the major word. We don't want to downcycle. We want to go away from linear to the circular value chain. And now comes a new item in our process, a new challenge. Europe already posed a need for digital product passports. So digital product passports, so far we have achieved the level of CE marking. And that means that there are clear standards for the quality control, for the certification, and for the followability of the whole documentation. Now we want to make it digital. We want to put a chip or a barcode on our elements, typical as for any product we are normally buying. It should be a digital product passport. This is really actual development at the moment at the European Commission. At the moment, they recognize two industries as pioneering products, so it's batteries and textile, and then construction materials are next. And then, imagine that we have now our digital product passport, so whatever we have dismantled, we have put it on the market. So we want to create new markets with the waste. And then we should use a supply chain matchmaking tool, which means it goes back to the new structure. A very simple example, and that actually was a part of the work also with Professor Bruwiller. A while ago, more than 10 years ago, we did a smart rail project, and this was a very small railway bridge in Croatia, it was decided to replace it, and it was replaced with a reinforced concrete bridge. Happily, we have saved that bridge. Otherwise, the bridge would be just put in the waste or melted as a new steel. We saved the bridge, and we brought it to the lab. We tested and assessed. And finally, we did the project with strengthening with ultra-high performance fiber reinforced concrete. This was done with the collaboration also with the Slovenian National Civil Engineering Institute. And the bridge is still available for the next usage. So let's hope we will one day put it in place. The idea came out of that bridge that we want to do even next level, to do a prefabrication of ultra-high performance fiber reinforced plates, which would be used for a strengthening of existing structures. And we applied for a project recently, and we won it from the Horizon Europe grant, and it's called Circuit. It has started just 2 months ago. Circuit has really the idea to develop a holistic approach by digital solutions, which should foster the introduction of innovative engineering practices, and should enable circular, sustainable, resilient, and smart transport infrastructure management. By mostly, we have to say, implementation of green public and innovation procurement. The project relies on 4 pillars: digitalization, recycle, reuse, and energy. And in each of them, we are developing a certain innovation developments, including tools and technologies, covering from the materials, bio-based and recycled materials, to development tools and digital platform. We have 5 pilot projects with 5 owners of the network. So one is in Croatia, Croatian motorways. We have MITMA, the Spanish motorways. We have Dutch Water Board, owner of the whole water or flood protection system. We have municipality in Slovenia, Črna. which actually this summer was the most hit by the floods, and several bridges were destroyed and gone with the flood. So we have to actually see this as an opportunity to support them in the recovery. And we have ANAS, the Italian motorway owner. The projects are covering all life cycle stages, and we have really obligation to show the development from the assessment, planning, and then integrating into the green public procurement, into the tenders, from development the digital platform and database to applying new types of asphalt, completely bio-based, to development of new solutions for the abutments and reuse of the construction elements in the bridge, and finally in the tunnel, a new system for the energy uses of, for the ventilation and lighting system. And another project which I have to promote as well is Beyonders. We are also partnered in this project. It's a project which is relying completely on the integration of autonomous and robotic systems, but how to help construction industry to become more sustainable and heavily focusing on the human robot or human AI-centric collaboration. So there are developments in the area of development of autonomous ground vehicle and aerial vehicles, additive manufacturing, which means 3D printing, smart advanced wearables and exoskeletons, which are helping workers to work to have a healthier and safer environment, and all that in the digital twin environment. So to conclude, how we should go further. We have definitely the technical knowledge to decrease drastically the usage of new resources and decrease the construction industry's environmental impacts. What do we need to do? We need to replace the primary raw materials with the high quality materials coming from the recycled construction demolition waste. We have to develop new innovative prefabrication solutions. We have to dismantle instead of demolish, and we have to assess and reuse. And finally, we have to establish a network or the platform where the supply chain should move from linear to the circular, which means we have to produce, enable a market for secondary materials and secondary construction elements. And thank you very much for your attention.
Thank you, Irina, for this presentation that I think will be very useful for the posterior panel discussion.
We go further.
But you should come with me because there is some appreciation for you.
Thank you very much. Can we take a picture?
So, picture is there.
Thank you.
Okay. So we close this keynote presentation now, and we just will start with panel discussion. So first of all, this will be co-chaired by Irina. We will try to moderate this panel discussion, and we have to start with the presentation of the panelists.
Yeah.
So Irina,
shall I start? Okay. The first panelist is Professor Rade Hajdin. Professor Rade Hajdin is a manager and owner of the infrastructure management consultant company from Zurich, and also a professor at University of Belgrade. He holds the PhD degree from ETH in Zurich. In 2001, after more than 7 years in the private industry, mostly as chief engineer and managing partner, he was appointed as a visiting associate professor at the University of Pennsylvania and was responsible for teaching and research in the area of infrastructure management. From 2003, he's the president of Infrastructure Management Consultants, a leading consultancy in field of conceptualization, with development and implementation of management systems. Dr. Hajdin is also professor at the University of Belgrade, responsible for PhD mentoring and consulting in developing a framework for management systems. Dr. Hajdin is active in professional societies, chairing a technical committee for civil and geotechnical engineering of Swiss Association of Transport Professionals. Dr. Hajdin also chairs Commission 5 of IAPSE on existing structures. He is a long-term active member of TRB, a Transportation Research Board, and IAPMAS, International Association for Bridge Management and Safety, Committees on Bridge Management. He is also active contributor in the Swiss Mirror Committee of ISO 55000 standard on asset management. Beside that, I can say a very active member in EUROSTRUCT and in the previous COST and one of the founders of the EUROSTRUCT. I will introduce then the next panelist. Yeah, we will go back. So the next panelist is Maria Pina. Maria Pina, professor, come to the front, sorry. Professor Maria Pina Limongelli is Associate Professor of Structural and Seismic Engineering at Politecnico di Milano. She has received her PhD in Seismic Engineering at Politecnico di Milano. She leads a group, SPM3, a Structural Performance Modeling, Management and Monitoring, a research group focused on vibration-based and INSAR monitoring, value of information, of structural health monitoring and structural health monitoring standardization. She is an active member of several committees and associations in the field of structural health monitoring reliability and serves on the editorial board of various international peer-reviewed journals. She coordinates or participates in several EU-funded international projects on structural health monitoring and performance assessment of civil structures and infrastructure.
So the next panelist is Dr. Alois Borwagner. He holds a PhD in civil engineering and started his career in structural designing in 2005 and has now been working at the AIT Australian Institute of Technology as a team leader for structural assessment and dynamics for almost 10 years. His research focuses on bridge engineering, structural dynamics, railway dynamics, and structural health monitoring. With his team, he's currently working on international projects developing a new railway high-speed load model for bridges, route-specific traffic data assessment, network-wide monitoring methods, and the application of artificial intelligence for degradation models of existing structures. He's a representative in various associations, FIB, Euronext, FEIHR, YAPSE, and national standardization bodies. And the fourth panelist is Nicolo Spiezia. Nicolo is a structural engineer specialized in algorithm development and scientific software. He has a strong experience in simulations and algorithms with a large number of projects developed and managed in more than 10 years, involving several competencies: numerical simulation, high-performance computing, data science, and machine learning, with many applications in the offshore and civil engineering sectors. Currently, he's working for NOCE in the field of bridge visual inspection. Nicolo Spezia holds a PhD in computational mechanics from University of Padua, and he has been visiting research a student at Stanford University and got business and administration Fulbright scholarship at Santa Clara University. So after this introduction, we can go to some of the points for further discussion.
Maybe for a trigger, I think Rade prepared a few slides for triggering the discussion.
Thank you. Do you hear me here or? Okay.
There is a microphone here.
Oh, there's a microphone.
Or the box.
Well, do you hear me now? Yes. Yes, what you see behind me is something you should know. It's a cataster. It's a very simple thing, right? Everybody relies on that. I know not a single civil engineering project goes beyond that, and also if you want to look into it to see who is the owner of this particular piece of land here, you can get there. This one is particularly from the city of Zurich. And maybe we can learn something from that regard to digitalization. In 1848, when the Swiss Federation was founded, a new one, there was a General Dufour. He actually was the first one who did the cataster. And this cataster was a good one, but there was a lot of problems with it because the signs were different. There was no standardization, what is supposed to mean what. And after some time, they start digitalizing. And also digitalizing was not so easy because everybody has his own standard. And you could really go there and ask for some of the information on paper, yes, but not digitally. In the meantime, there is no discussion anymore. We do know how to deal with this data. They are publicly available. You can just plug in, you get everything you want, and you can start making a project or you're looking for a reconstruction on your house or whatever that is. So This particular thing is publicly available. This is a GIS system from the city of Zurich in this particular case. And you can, every single of you can go there, you can build a small interface and get all the data, and there is no problem whatsoever with that. So how they did it? Because there is a standard currently, governing standard in Switzerland, which is valid for everybody, and nobody questions that at all. It is something that is just working. Now, if you look at the next slide, we did the next step in this direction. And this is something is also publicly available. It's a 3D model of Switzerland, generally speaking, with all the houses. And you can see here, even, I can show you here, there is even a bridge here. This bridge is very, very primitive. It's just a small quadr, you know? It's a parallelogram. But again, you can replace it anytime, and it's relatively easy because they made also interface to that. We can replace with the BIM model if you want, of course. They are still not a standard how you can get hold of this data. But we are on this way to it. So my question, the first teaser here is, who should do that? Is it really a responsibility of engineering consulting offices or a contractor to do that? Or is somebody else responsible for that, mirroring the experience with the catastrophe that has been found in 1848? So this would be the first question from my side.
To yourself or? Okay, so shall we open discussion? I think. Now the questions are all around the digitalization. I think with who should do it and how. What's the way forward? Should we invite the audience? Yeah. Okay. We will throw the box if anybody.
Or we can go to the other questions.
So there we are.
I think this is very interesting, of course, questions, and I think your keyword is standardization, right? I think this is really the important keyword, creating standard, and this is I would like to add something to this question because I see the data, so the results of the standard, from the analysis point of view. So my job is developing algorithm and make analysis of this data. And the 90% of work when you deal with data is about cleaning and reordering this data. And the reason is because there are no standard many times. So the data are just collected in many different ways. You need really a lot of work to put the data in a correct order. So this is a second aspect that I would like to underline, that having standardization in the data structure, it's fundamental also for not only for viewing the data, but also for analyzing it, making some increased knowledge, apply some, I don't know, machine learning, artificial intelligence. So I don't have right now a clear answer to your question, but I would like to underline how standardization is also necessary to post-process those data. Otherwise, the risk, and it's extremely common around, is that we collect many data because it's quite easy, but we are not able to analyze them because they are not in a good standard. So who should your original question was who should do this part of the job? Probably from my point of view, like every complex problem, it is a collaboration between different stakeholders. So probably the public body probably played an important role in creating the catastrophe, and so I think that the public stakeholder has a role in this, but on the other side, technical people, so engineers, so infrastructure owners, so consultants, so research at the university. It's I think I know it's a trivial answer to your question, but I think that at least there's no way other than collaborating between public, engineer, technical, and creating a standard, hopefully this is my view, at an European level. Otherwise, all we create is small standard for single infrastructure owner.
Other comments from the panel?
Just to make a short comment, we do live in the real world, right? So if you leave that to the industry or even to academia, there is going to be produced a myriad of different standards. And we cannot do that. I mean, this is not the way. I made an example of Switzerland with the digitalization cadastre. This was a mess at the beginning, right? Everybody is doing something else. Every time you use theodolite and surveying instrument, you do something else. So this is not the way to be done. So it has to be done on a higher level. And I believe it's a government responsibility to go after that, especially if it's the same thing with the cadastre. We can help, of course, as researchers, but it's a government responsibility finally. And only through that we can have it's an infrastructure problem in sense, not of civil infrastructure, but a societal infrastructure to deal with that.
Maria Pina.
Yes, I want to pick up on some themes that were raised by Nicolò. First of all, the standardization. I completely agree with you, which is needed. The problem with civil structures and infrastructures is that it's very difficult due to the differences between items. I mean, if you have to standardize an industrial product, industrial products are more or less always the same. So you define, I don't know, even for a wind turbine blade that was presented by Irina, there will be thousands of the same wind turbine blades. So you design a way to collect data, and this will be repeated. For a bridge, it's much more difficult. For a building, for any civil structure, it's much more difficult, the standardization. How to deploy sensor on a bridge? You don't have one single answer. It depends on the bridge. So it's challenging. It's really challenging. Nevertheless, it's something on which we have to work. The research should work on this. The second topic is collaboration. I agree also on this point because this topic is interdisciplinary. We are talking about digitalization and sustainability. Is even difficult to match the two. I had to think about it to prepare myself for this panel because it's not so easy to match the two. Concepts, because digitalization by itself is an activity that, if it's not performed carefully, is not sustainable. If we collect data just because they are data, and we collect a lot of data, it's unsustainable. We have to collect the data, we have to deploy sensors, and this, in 30 years, even less, will be waste. If we process data, we have to use high power computing tools, and they produce a lot of heat. So the entire data management process is, let's say, uses resources. And we have to be careful with it. So this is we need collaboration to make digitalization sustainable. And also because by itself, it's an interdisciplinary, let's say, digitalization itself has many needs, requires many expertises. And the last point I already tackled, it was a lot of data. So maybe you want to.
Yeah. Thank you, Rade, for your question. Who is responsible? Who should do this? I think this is a central question we have in the sustainability. We all are responsible if we want to tackle this problem, and we need a strategy. And somebody has to define the strategy. And I fully agree with you that here the governments, the bodies should define the goals, should take the knowledge of us all to define the strategy, And then it's up to us and to design this and to follow this. And of course, I fully agree with you that we need standardizations. We need it all the way if we are doing quite a lot of monitoring. So if we use monitoring data for safety aspects, if we want to extend the service life, we have to also think about the standardizations, how to take this data, which sensors we are using, and all this way, and also what we do with the data. And standardization and harmonizing is a huge topic to gain sustainability and to digitalize. And of course, it is a hard task to do, because that guy is collecting the data, that just do it in data, and somebody else is doing maybe something bigger and has a bigger view, a bigger view in mind, and that's the thing, we have to come together. And that's why I like this organization here, EUROSTRUCT, so much, because we are doing that, what we are doing. We are connecting us with share knowledge, and I think if we share knowledge, cooperate much more, we can succeed.
Maybe to trigger a bit the discussion in the other direction, so we definitely need, but are we properly using the existing data? So what Rade showed, there is a lot of available data. And I have impression that if each owner of the house, or in the future, each user, not in the future, already each user of the road would become aware of what is there and how the data is used, there might be intrinsically a need to do better usage of the data. So should we more educate the audience or a general public? Do you have any experience? So, meaning that when I look at the cataster, you know, the need comes if each owner of the house knows, okay, there is a super valuable information. For instance, if I know the angle of my roof and the surface area, can I put the solar panels, and it will influence my bills? If the same thing we would apply to the roads, there might be a completely shift. So we take a lot of responsibilities, I think, on a very small group of people. But
let me give another pitch on that one. I show the cataster, right? Do you see in this cataster how many rooms do you have in these houses? Do you see there if there is a heating with a heat pump or something else? You don't see that. Yeah. And it's good that way. So there should be a stratified data. That's up to your question. So I see the basic things in cataster, which I can use for my own purposes, and then I can use it even if I have 3D model, like just the hull of the building. I can start using it for my own purposes. I can introduce that I have a heat pump there, that I have some kind of heating there, that I have so many floors, that I have a roof which could be used for these purposes. So there is also stratified thing, but the basis is still there. And that is actually the second pitch from my side. Yes, the government should be responsible for something like that, but not to the last extent, because there's also a privacy problem with it matter. So, but it has to be the basis. So this is another pitch from my side on that one. Actually going in the same direction.
Okay.
Yes, may I make a comment?
Of course.
Yes, I think this point that Irina raised about the need to, let's say, train people to use digital tools is very, very needed. Is something without which we cannot really digitalize our environment. Rade, and I agree, said that this should start from the governance, the digitalization. This is the starting point for sure, but then we have to work to involve people in this process. They have to be convinced that digital tools are useful. As now people start to be convinced that we need a sustainable approach to waste. In all our houses there is we differentiate waste. Now we are convinced to do it. But 10 years ago it was not like that. In some parts of the world it's not like that. So one direction is that we have to really involve the citizens in this process. And one way could be, for example, crowd sensing, I think, is a very powerful tool. Now there are several studies on how to collect data with our mobile phones. This is a very effective way, I think, to make people aware of the potentialities of data, of what we can do about this. And another point is training the workforce. Now, these digital tools are also a problem from the social point of view, as progress has always been a problem for workers, because many things will be done by machines. And then what these people will do? So we have to reskill these people. We have to reskill these people so they learn to use other tools to do the job. And this is a very important point with an impact on society.
Yeah, Maria, you talk about impact on society, but what about impact on education? Because as civil engineers, we have, at least myself,
of course,
I have not been trained on this digital world and so on, and it's something new for many people. So this, in some way, should be also introduced in the new curriculum, educational curriculum, and so on. What do you think about how?
Definitely.
Because we cannot learn everything. We cannot learn bridges, structural engineering, and also digitalization, management of data. How can this be integrated in the?
Definitely. But when I speak about upskilling and reskilling our workforce, I'm not just talking about the inspector on the bridge. I'm talking about, for example, PhD students or master student engineers. For example, in our master curricula at Politecnico di Milano, we don't have courses on structural health monitoring, for example, or sustainability is more a topic. I mean, we have green courses, but still it's the beginning. And also for PhD students, there are courses, but the digitalization is something that should be much more present now in this curricula. Now we have a recently funded project on the Marie Curie project that will fund 16 PhD students who will work on digitalization of bridge integrity management. This is a very I think is a very important project, and I hope this will be the start for further development in this sense, to create PhD courses on this topic, which are, this is very important, a collaboration between academia and industry, because without this, we are not going to bring it to the market. This is a very important point, I think. I don't know if I answered your question.
I would like to know the opinion of other panelists about that. If this should be included just in the PhD programs, or should be also in the bachelor or undergraduate, because many of the people graduating in bachelor, they will go to work and they will face these problems. So they should have some knowledge about that.
Okay. Back to your question, Irena, are we using all the data which is available? Of course not. One example, it took us years to convince the stakeholders to use road monitoring data, way motion data from rail or road. They just had it for load enforcement and taking out heavy loaded vehicles. And this is a perfect impact data what we can use for doing assessment of our bridges. And we worked now a few years on that topic, and it was possible to assess the real load on the road, real load on the rail. And yesterday I had a discussion with Eugen Brüggeler, for example, in Swiss. The loads they are traveling on the road are about 50 to 60% what's in the code design level. And that's a huge amount. And also if you use fatigue assessment, it differs. If you use freight trains or you have personal trains, you have much more harmonized load deflections, so you can increase your service life quite a lot. We had some examples where we could extend it with a factor 4 and much more. And of course, there are a lot of data available from the stakeholders. traffic management data, toll data, video data, all this can be used for monitoring reasons and some privacy reasons and also some legally reasons. But we think if we overcome and convince them the usability of this data, then they also overcome the policy reasons, and then it might be quite more effective. And education, of course, we need educations, also in the education at university borders, but the young people are digital native and sustainability natives. I also think we have to focus on the governmental bodies and also train the stakeholders, because they have the databases. They have the databases of bridges, they have the databases of infrastructure they're using. And how to train them and to convince them that this is really necessary, I think this is also a good task, and EUROSTRUCT has here quite good tools and educational problems, and thank you for that and for the initiative.
It's interesting, maybe just also the comment, in all our projects we have to convince whoever is a founder of the project that we are very multidisciplinary. We are combining computer science, social science, and humanities and engineering. And then in the education, we still stick to very traditional separation of civil, mechanical, electrotechnical, computer science. So there has to be a change, I think, a significant change in the education. But
yeah, but not only focusing on engineering, because this topic is really interdisciplinary in a very wide sense. It involves social aspect, legal aspect. If only you think to the problems of cybersecurity, who has to check the data, who owns the data. So here is really a word around only digitalization and not to talk about sustainability. So, and this, sorry, I speak too much, just one last thing. And also this makes difficult to bring it to the bachelor level, coming back to your comment, because, you know, at the master level and at the PhD level, you have students have a wider preparation, but at the bachelor level, it's really difficult to integrate this aspect. We have to try, but it will be...
Because if you introduce these subjects, you have to remove other ones, because the time is limited.
Also, yeah, you're very right.
Yeah, probably you can go, we have been talking a lot on digitalization. The other subject of the panel is sustainability, so probably you can move to looking at this. There is this question of asset management systems. Do they include sustainability? What is your opinion?
The answer is relatively easy, no, they don't. I mean, I'm talking about the ones that are productive, not the research one, the ones that are using in a practice, and I know quite a lot of them, and very few of them use sustainability, and let alone that the owners and operators of our infrastructure are really, even if the possibility is there in the systems, that they use it. They are under pressure because of money. They try to do stuff as good as they can, and they try to, in particularly, to fulfill the budget. So these are the constraints there. Could it be done? Well, again, coming back to the same procurement and the rules for procurement and the state or the owner responsibility regard to that. There are some changes there, and it's going to happen in the future, I believe. And then we can talk about sustainability in asset management. There is one more thing that I would like to mention here with regard to sustainability. I mean, if we have this kind of presentation that I just showed, where you have infrastructure, bridges, retaining walls, everything in a system which is available to everybody, you can also do certain kind of sustainable decisions with regard also to the recyclable materials, and because you would know in GIS system, which is based like that, where you can get sustainable material and then use it somewhere else. This is currently not the case, because every contractor is taking from somewhere their materials. If you have that kind of idea, and that's probably some of the things that you presented here, then you can of course enhance quite a bit. And this is a part, of course, also of asset management system in itself. So yes, the answer is no, not currently. That can be done. We need a procurement, that's another one, that the state has to, or the administration has to do the rules for that. But even then, we can make an enhancement if we include this kind of representation that I show here in the future.
Maybe, to give a little bit of an optimistic view. So, do you know, any of you, some good examples where the sustainability KPIs have been included in some decision-making process? Alois? Okay.
Yeah, because we talk about performance, no? Assessment by performance, so...
The thing is, what are you talking about sustainability KPIs? I mean, the question is, if you think on bridges, at least how to deal with it. I mean, we can focus on the material side, and there we know the CO2, we knew the resources and so on. But for me, sustainability is a bit a broader and wider context. So we have to define first the boundaries. Is the traffic included or not? So if the traffic, I mean, you want to have a bridge and want to go from A to B, and you need CO2, and all this must be included in my point of view. Also, the construction, they exist if you do interventions, or you don't have to do this if you do monitoring and can extend the service life. If you take material A, that lasts for 80 years, take material B, it lasts for 120 years, and if you take EU Habit C, maybe, I don't know, forever. And to define the sustainability KPIs is a bit a difficult task. And yeah, we had some examples for load assessment, where we did the load assessment on bridges quite close here down in the Danube. And it was possible to reduce the assessment or the code loads up to 12–15%. So no intervention was necessary, and this was a sustainability gain. Yeah.
Okay, maybe to move a little bit to Nicola.
Yeah, so I'm, to be honest, I'm not an expert on sustainability. I'm more related to, let's say, the digitalization field. But in NoC, we are developing this software for image analysis from concrete bridges. So we automatically take images and we analyze these images to understand the risk and the priority of maintenance. And we have this strong partnership with the Sonum in Copenhagen, which is the owner of the bridge infrastructure on Denmark. And what I understood from them is that they understood this, that if they can perform a very accurate image analysis on monitoring and automatic visual inspection of their infrastructure, they can really extend significantly their life. And so this is why I see really this interesting correlation between digitalization and sustainability, because I'm working more in digitalization, but I understood that there is really a true value. I mean, they see really a true value if they can increase of 10 years, 20 years with accurate maintenance of the bridge, they can really save money. So sustainability is not just because we want to live in a better world and a greener economy, but there is also an interest in saving money for maintenance, and I think, I mean, this is it's a simple concept, but I think it's really interesting, and that when we want to promote this digital, for example, monitoring of the infrastructure, it is because we really want to find more objective and more standard way to extend the life of the infrastructure. And in this, I think there's a good collaboration between these two mainstream and.
Yeah. Thank you for bringing back the connection between digitalization and the sustainability, because I think this is the point, the real point. At the beginning, I said that they can be competing concepts, but actually, I was giving I was taking for granted that this digitalization is a tool to achieve sustainability, exactly for what you say, that if I can summarize, digitalization provides information that allow to optimize the management. Whatever management we are talking about, we can talk about integrity management, and this is what you said. With information, we support decisions that optimize the management. But could also be, let's say, service management, like traffic flow, for example. If we can collect information about traffic, we can deviate the traffic and reduce the emissions. So there are several examples on how information provided by digital tool can optimize the management. So this is for sure. My point before, I don't want to be misunderstood. My point before was that let's account that we don't have to collect too much data and then don't use it. It's just this.
Okay, I want to trigger, Nicola, our next question. Do you believe that machines will make better decisions than humans?
Wow.
This is a very difficult question. So right now, I have this feeling. This is really my personal vision on this. So where we are right now, and I completely agree with the aspect that the bridge civil infrastructure are characterized by heterogeneity. So every bridge is different. They have their own history. So machine works very well, you know, with standard data where everything is the same. This is not the case of civil infrastructures. So at the point where we are today, it's still that I think that the human knowledge, the experience, the engineering knowledge plays really an important role. But I think that this will change really fast. So we have this data from the US. And we have a strong partnership with IBM, so with the Watson system, and Watson has been one of the pioneer, let's say, machine learning model in healthcare. And what they are telling us is that the triage, so when you call to the hospital, the understanding of the diagnosis based on the information, the basic information that you got from the telephone. So now the machine is working much better than the person. So the doctor has a higher rate of error with respect of machine. And these are the data that we share with the IBM Watson in New York. And the same is happening for radiographies or image body scanning and so on. So right now the machine is performing better for some specific task. So what it's and I think it will be like kind of the same for I think for some kind of inspection in civil engineers. So sometimes it's difficult, you know, to watch 1,000 of images, and it's difficult from the human brain. What I believe the machine will not be able to perform and is the big picture, right? It's like the doctor usually can have you know, a whole overview of the person. Is not like focusing on the single aspect. And this is kind of the same for civil engineer, you know, for infrastructure. So sometimes having the big picture, it's extremely important. But I think that in a couple of years we really, I mean, it's really outstanding what we are seeing from. So we are now collecting images with drones. The quality of these images is incredible. I was really surprised by what we can achieve with drone images. And I'm sure that in a couple of years the quality of the drones will increase, the quality of the sensor will increase. And yeah, so I think we will see really a faster increase of this. with this vision that, in my opinion, the machine will not replace at all the civil engineer, but it will help facilitate the screening, for example, images. So if I give you 100 images and I can support the civil engineer and just let's focus on these 10 images or 20 images, because I'm confident that the 80% of images are not important. So this will really, I think, facilitate, and in this, to answer your question, yes, I believe machine algorithm digitalization for sure will help. There's no doubt in this.
Rade, will you rely on the diagnosis of your health based on artificial intelligence, or you will prefer the opinion of a well-experienced doctor?
Well,
As I rely on a blood test,
well, I'm referring to Theranos with regard to that and the scandal that was there in Stanford University. But as some of you may know, I have an intimate relationship to Roche Pharmaceuticals. So you may know that, right? So I have, and my wife is quite a bit in digitalization in pharmaceutical industry, and she is in personal health medicine. And she wouldn't agree completely with you, right? She's, of course, in cancer research, so it's a little bit different. But based on that, the DNA and data that they collect, it's always a lot of problem with the privacy, of course, and this kind of stuff. But even then, there is a lot of things that go wrong. That the diagnosis of certain cancer, for example, HER2, for the ladies, they would know that breast cancer is probably automatically being caused by this genetic aberration, which is called HER2. But this is an easy one. There's a lot of others that she wouldn't agree with your assessment. And that's the reason that I wouldn't really trust a machine to make a diagnosis. That said, I completely agree that the stupid task of looking 10,000 pictures, I refer here to your country as well, and San Giorgio, Viadotto San Giorgio in Genoa, where they're collecting every year about 15,000 pictures, right, of the steel structure, which is completely new. Maybe not a really good thing, but if you do it with the machine learning, you can do that. But keep in mind, currently, machine learning, deep neural networks are the fancy name for regression. For regression, for a simple regression. These things are actually good if they are in a domain. If you have data in the domain, they are perfect. They can help you a lot. If you go outside of domain, they are not good. So I really don't believe that the machine can make a design of Zunibrek Bridge in Switzerland or the Cantor Bridge, because that was way out of the line of what was being done before. So put down the things on the earth. Yes, it's a useful tool. It can be useful in the sense that is easing our job, facilitating our job, or making no stupid things, right? But it's still at the current state of being not any kind of creative tool. And that's where it stops. Does it answer your question? Yeah. Okay.
If I may add to what Rade and Nicolò said, and I agree on their points, I think machine will never replace a human. For a problem of data is a practical problem. Machine learning works in this way. Feeds with data a black box, and the black box learns what the data mean. Now, the problem is that if you give this machine a data that she has not seen before, she will not know what to say. Now, my point is that we will never be able to train a machine with all the data. In civil engineering, in civil engineering. There will always be something that the machine didn't see before. So I would never trust a machine to make the decision. We can, as Rade said, for for ordinary tasks, when the task is really repetitive and you are sure that you train the machine with the full set of data, then yes. But the decision made by the machine in a general sense, I wouldn't agree.
Yeah, thank you for the interesting question. I had once a comment from a very famous guy. He said, yeah, artificial intelligence does not compensate natural intelligence. I was always thinking this way, but then ChatGPT was happening, and I said, wow. And in research, we did quite a lot of AI applying methods on track condition monitorings, repeating tasks, and it worked remarkable well. Diagnostics which hardly could see before, and also if you apply them, it is really a powerful tool, and it is increasing because we're getting more and more computational power every year. Quantum computing is coming soon, so there will be really big change outside and also here in our world, in the civil engineering world. And what we can civil engineer doing quite well, we are creative in finding solutions. We have to do that, and we are trained to that. And so we can use machine learning and artificial intelligence as a new tool to trigger us for better solutions, to find new designs. And of course, creative parts would never take part, and also where you have no databases. But I wouldn't neglect that. So I really think it will play a major role in the future, more than we think.
Thank you. Okay.
I don't know whether you guys played with ChatGPT, but you probably would. And I played quite a bit, and I use a lot of word plays, right, in German and English. So the meaning is not really clear. So you write a sentence, something that you would do colloquially, and it breaks down. ChatGPT breaks down completely in that. It's very good if you ask a simple question, but you start playing with words. If you're using even in a poems, use the words that the rhymes in the poems, and put in GPT, they break down completely. It's even start to be emotional, which is kind of crazy. So, play with that, and then you see the limits very, very soon.
Yeah. Thank you very much. Yeah, that's true. And also, what's also interesting in ChatGPT is that it was working better in the beginning than it is working now, because more artificial data is available. So, that makes sense that natural intelligence is still needed.
Yeah, that's a very good
Sorry,
conclusion.
just one last comment. But I think ChatGPT is a very good example of how the interaction between the machine and the human can give very good results. I mean, my students, since ChatGPT, they start writing wonderful things, honestly. Yeah, but because it gives idea. Then, of course, the stupid student just brings you what ChatGPT wrote, and sometimes is, as Rade said, is something crazy. But if it's used by by the bright students, that they change, they use their intelligence, the mix is good. So I think this demonstrates that the machine and the human is the solution also for infrastructure.
That's something I wanted to say in the end, but we shouldn't be afraid, I think, of AI taking over, and it's definitely the future, and we should use it in a smart way. Is there any question from the audience you would like to ask? Okay, now we will play this game. I will throw you the box, and you have to catch it, and then you have to talk looking into your box.
In the black.
You want it? Okay. So you just talk like this, hold it and talk. Yeah,
this way.
Super.
Okay. I'm Corrado Chiseri from the University of Campania in Italy. My question is about the issues of digitalization. We have mentioned some of them: privacy, who owns the data, and so on. But my question is about machine learning in particular. Explainability is a topic that I know is currently investigated in research. How to make AI explainable? What is the risk of assigning safety task to machine in a way that we cannot explain why it selects that picture instead of that other picture. And what is the responsibility of the owner or the person whenever a disaster happens because of this?
I think question for you, Nicola.
And sorry. And so my final question is, do you think that the explainability will be something that will be required whenever we get to a standardization of these digitalization tools? Thank you.
Always my vision, very, very important question. So my answer is we cannot give explanation to a pure machine learning model. There's no way to explain a pure machine learning model. So most people here are engineers. So mathematical models subdivide, in physics-based model, FEM, particle methods, which are based by equation, and on the other side, black box model, which are machine learning, data-driven model. I can't tell you why I get such result from solving a differential equation, but I cannot explain you why we get that result from a machine learning model. And there is a huge trend right now in explainability in machine learning and so on, because I know that we have this problem, but from my opinion is that if you use a neural network, you cannot explain the results. I mean, you can test it, you can, and I completely agree that this open a big question, which is, for example, autonomous vehicle. So in San Francisco, now they are working with, they are driving with the autonomous vehicle, and this is a.
Maybe we can learn anything from that experience.
Yeah, so I believe that explainability is a huge problem. There are people that saying that now they are developing this machine learning, explainable machine learning model, but I don't believe it. If it's a machine learning, it's a black box model, so you can just justify, but you cannot explain.
Then again, we come to the human importance. Can you throw the box behind you? Jochen wants to ask the question, so throw it, that's the point. Yeah.
Thank you. Yeah, I just want to follow up with this discussion. I think it's very important when we talk about information and information that is contained in data, that we don't forget to integrate the information that we have in traditional engineering, like from our mechanical models, from our understanding about causality. Causality is actually the key word. In classical statistics, causality was always ignored. So it's a rather new concept to try to combine statistical methods with causality and causal reasoning. And you have such models. They are not machine learning, but for instance, Bayesian networks. I would call them white or light gray models. You almost know what is happening and you see the causal relationships, but they have, of course, very strong limitations when it comes to handling of big data and complexity. But I think research, and that's maybe not us, that's maybe data scientists, they should really try to advance how we can combine traditional engineering knowledge with data, because we cannot throw away all this knowledge about models.
Yeah.
There is one, Professor Bergmeister, very good catch.
Yeah, good point. Good.
So I would like to summarize a little bit what have been the main points till now about the discussion. First of all, I would like to come back to what Rade was saying. In 1808, Napoleon developed actually the first cataster. Why? He wanted to know he is the owner of the properties, and he wants to ask for taxes, money. So coming back today, actually the public is the owner of the infrastructures. And therefore, they must order circularity. They must imply in their procurement, in their tender, the digital design phases and which data should be collected and maintained. This is something which is not a need, but this is a must. Coming back to the digitalization, to the standards, I guess that we have to develop in a fast way design guides in order to standardize something, but not codes. I would like to remember what Jochen told me yesterday. In 2010, the so-called model code was developed. And in 2027, the content will be included in the Eurocode 2. So this is almost over. And a third issue is related actually to the digitalization. I mean, we are teaching at the moment in a completely wrong way. Who is able of my generation to teach BIM or to teach digital design? Nobody, including myself. And therefore, we have to change the way how we teach. We have to combine experiences, try to invite experienced engineers and promote the young generation. They are much more trained in digital issues, and they are much more trained also how to deal with digital apps and so on. And the last issue is actually, when should we start? Now, otherwise it is too late. Yes. And who should promote that? I mean, the owner of the public infrastructures, the European Union, must try to imply for their new constructions, and they are spending on a yearly level approximately 5 billion of European money, European euros. And they have to imply in their procurement, in their tender documents, circularity. They have to imply actually the digital design methods and so on. I was responsible for many years for a huge infrastructural project, and I know exactly if we did that, then it was followed by the companies and by the design offices. But if the owner doesn't do that, nobody will promote such a new important generation in order really to transform digitally our common engineering work in a sustainable future.
Thank you very much. Helmut wants to ask the
Not ask, but to complement that, you know, in practice, what we need is what was discussed in the beginning. We need some standards and guidelines that help us. Other communities have achieved that. The seismic community, for example, the European Union is financing those institutions. In China, they have an obligation to do that in projects of a certain value. So there are examples, but we failed together with PINA. We were trying to promote this in Brussels, but we failed to do that. But maybe this community can try to establish something like that. In Europe, we have trans-European networks. These are, well, more or less somehow managed by the European Commission. Why not asking them to establish something like a European, well, relevant body to take care that all of these things are introduced into this process? This would be a progress we can achieve.
Thank you. Vikram. Works very well.
So I just wanted to comment on two things. One is I'm naturally a slightly more pessimistic person. So one comment is that with all these data science and digitization, I think apart from the existing problems, we also now have a new problem of there is a very high expectation while playing with these toys. And I sometimes see an almost toxic positivity in them. And I think we need to measure down our expectations from these things. I'll go back to Radhe's point that we live in a real world. And we should not move away from the fact, why are we doing these things? I would also like to compliment Konrad's and Helmut's point here that we have to do it now, and this is an amazing group which can possibly make it happen. So maybe from EUROSTRUCT, we can take up one or two very tangible directions in this regard. And those of you who have not joined this organization but are here in this conference, perhaps you can consider joining EUROSTRUCT to make this happen.
Thank you very much. give a close.
Very interesting discussion. I don't have any comment now, so, but we have to finish because before the coffee break, there is a photo of the group that will be in front of the main building. So somebody will drive us to this place.
And
so
before that, we just have to thank to our
to thank and to give them this appreciation. Thank you for your collaboration.
Maria Pina.